Hello, good morning.
Good morning, sir. I'm Devkishan Patel, welcoming you all to the day 5 FDP on the blockchain technology and its application. Am I audible to everyone?
I can hear you.
So today our first session is conducted by Mr. Yash Sharma. Today he is going to teach us the Hyperledger and Hyperledger Fabric. Over to you, sir.
Thank you, sir. So slight correction. Today we will resume what we were discussing about Ethereum. We'll not begin with Hyperledger, or maybe towards the end, if we have some time, if we are able to finish Ethereum on time, then we'll get to Hyperledger. But there's another session that we planned for tomorrow, in which we will study the core of Hyperledger. How do we set up a business network, and how do we deploy a smart contract? So today is going to be essentially a continuation of what we were doing in the last session. And just like every session, before I begin, feel free to ask any questions, uh, any issues that you ran into while trying Ethereum, or anything at all related to the sessions. All right, I'm assuming there's nothing. Just a bit of housekeeping. Just a bit of housekeeping. I will be taking a very short water break for about 3-4 minutes at 10:40, and we will resume very quickly after that. And I'm sure you're all familiar. We've changed the plan a bit. We are going to have two sessions, one today and one tomorrow, instead of both of them being conducted today. Having said that, we yesterday, just a quick recap, we talked about consensus in the first session. We took a look at how consensus can be implemented in a very typical and very simple blockchain project, with all the verifications related to consensus coded in that demonstration that we did. And then in the next session, we talked about Ethereum, more specifically the development environment for smart contracts in Ethereum. We deployed a very simple smart contract in 3 locations: one inside Remix, second inside Ganache, which is a local blockchain that you can set up, and third on the testnet. And we were able to test the smart contract, but it was a very simplistic contract. What we will start off with today is to understand some other elements of Solidity, after which we will build our own blockchain, and we will connect MetaMask to it. And if time permits, then we will try to deploy a token, a cryptocurrency development exercise where we'll create our own cryptocurrency. Having said that, we were on the Remix environment yesterday. I'll reopen that again today. We'll be doing some small snippets of code. So we saw yesterday that a very simple smart contract looks like this, with one state variable and some functions, which comes pre-built when you launch your online Solidity environment. And then we deployed this contract at numerous places. We saw a couple of transactions being made to the contract. Now we're going to talk about some basics of Solidity. And for doing that, what I have is a set of demonstration contracts, and they are about 37 in number. So, and each one of these contracts, they're like contract files. Each one of them demonstrates a specific concept related to Solidity. We will not have the time to run all of them, but we will still look at the code and do a quick walkthrough of how that code might work. So the first thing that we need to see is conditional statements. So for any programming language, running conditions or control statement is very critical. So Solidity allows us to implement two kinds of conditions. One is a normal if else condition, which you can implement very simply like this. And it could be like extended if else, where you could have if, else if, and then final default else. So for those of us who are, from any programming background, they'll understand what this is. This concept is present in almost all serious programming languages in some format or the other, mostly in this format. And this is identical to the JavaScript format. The other thing is that some languages, not all of them, they provide a ternary operator, which is a shortcut for a very quick if-else statement. So this is how a ternary operator works. You have a question mark keyword, which is preceded by a condition. And then post the question mark, there are two outputs that are split by a colon. So what this means is the value that will be returned from this entire statement will be 1 if this condition is true, but it will be 2 if this condition is false. So it's a very simple concept. Now we can very quickly run it. So I'll run it inside the VM that's provided. I deployed it. Now the first thing is I want to check whether these conditions work or not. If x is less than 10, then it will return 2. Let me try that. So x less than 10 could be 3. Sorry, it returns 0. So I've got 0. Now if x is less than 20, it will return 1. So let's put 12 here. I got 1. So it's really a trivial sort of an experiment. If I put 21 here, it will just return 2. This is slightly more interesting. If I put something less than 10, would return 1. And if it's more than 10, return 2. Now, one other thing that is typical to Solidity, but not extremely typical, other languages also have that, is the condition of over and underflow. What that means is if we try to enter, let's say, a negative number in an unsigned integer, then it doesn't give you an error. It reaches a condition called underflow. What that means is it will give an unpredictable result. For example, if I give a negative number here, and I try to, hang on, there is an out of bound error, but if this number was inside the contract and getting assigned a negative value, it would allow that. Let's say if I wanted to do something like this. Anyway, we'll experiment with that in a bit. Let's take a look at some of the other contracts. So we looked at the function construct in our storage contract. The other thing that basically defines a contract is, or is important to a contract, is the constructor. So let me see if I can demonstrate it here better. So a constructor is a function that is called at the time of construction. It is, again, not limited to Solidity. Most programming languages have a constructor type construct. What constructor does is it allows you to set up the state of the contract. And constructor is called when the contract is being deployed. And if we look at this contract, let's see if it's compiled again. Then when we try to deploy it, let's say I try to deploy the contract X, then during the time of deployment, it's going to ask me for the value of this string that I'm trying to enter. So because during deployment, it's calling constructor and it needs a value to be assigned. That is why it basically needs that string. So if I enter a string here, I'm going to deploy the contract. And what I can see is, so this is a public name. I've deployed X. If I check the value of name, it will give me the initial value that I had set, although I've not called any function to populate it. The other, so actually there are a bunch of them. The other one that I think we should talk about is arrays. Again, arrays are not something that's limited to Solidity. Arrays can be declared with the same square braces like most of the languages allow. You can declare an empty array, or you could declare an array with some initial values. You can also give the size of the array. The good thing is you can create an unsized array and keep adding values to it. It will dynamically keep expanding the array. So if you create an array like this, you can keep adding value like this, arr.push, and it will keep accepting it. And then you can remove from the top or the last element using the pop function. Now, one thing with arrays is that they can be of native types or primitive types, or they could be of an abstract data type also. So what we mean by abstract data type is defined here. So C++ has this construct called struct, which is a combination of different types of variables. For example, you have a struct to do. Then you can, in this struct, you can define any kinds of primitive or non-primitive types that basically combine together to define your to-do. So if you have a to-do list, for example, then the list would have the text, what is the task that is to do, and then a flag that shows whether it's completed or not. And then you can have an array of to-dos. And then you can create to-dos by accepting a text. You can also get an array, individual elements. You can get the array value by index, which is basically the index at which that certain element is. So an array essentially operates like any other language. Then some things that are specific to Solidity, which are not there in other languages, are number one, how do you call another contract? So the way to call, let's say, a contract that is deployed at a certain address would be using an inbound, an internally defined global variable called ABI, which allows you to encode the signature of the function that you want to call in other contract. And then once you've encoded it, you can just call it by calling .call, passing in the encoded signature with the values that you want to send to that specific function call in another contract. So this is something that will not really test, because in memory blockchain will not allow us to deploy two contracts together, but it's something that's used very frequently in contract development. So let's see. The other important thing about Solidity is some of its global variables. One of those was the ABI that we just saw. And some of the others are message or MSG. One moment. A message is defined inside a contract when you want to access who's calling the contract. For example, let's say if we want to go back to the storage contract. Now we are calling the storage contract by a certain address. We know that. So if we want to know what that address is inside the contract, then the way to do that would be to use MSG or the message construct, and then use its internal field called sender. Now this will give us the address, and what we can do is we can match it with any specific address so that we basically control that access to the function. And this is used very frequently to ensure that if the function should not be called by someone or some address, or should only be called by some address, then we can use something like this. And the way to do that is like here. To define something called a chairperson, which is of the type address. That address is the wallet address. And here what we're checking is, or what we're doing is assigning chairperson to message.sender, which means that we're saying that the chairperson becomes a person who is calling this specific function or calling this specific constructor while deploying the contract. So when a constructor is called, the account that is deploying the contract is populated in message.sender, which means the chairperson becomes the deployment account. Now, this is a pattern that's used very frequently to identify who's the owner of the contract. And it's something that you can see in this other sample contract called owner.sol. In this, what we're basically doing in the constructor is assigning the owner to message sender. Where owner is a field that basically can have any address. What this does is that we can check who is the owner of the contract. So we can basically call get owner and check that a specific contract was deployed by a specific owner. You can always change the owner, but you have to be the owner to change the owner. Now we can check this very simple contract quickly. Let me remove the older ones.
पापा कब है मेरी?
Sorry about that. So let's deploy this contract and see how it works. Now it's been deployed here in memory. Let's say let's first check with which address we deployed it. This is the address. So let's copy this address and have it available for comparison. Once we've deployed it and we have the owner, we can retrieve the owner and let's see if this matches. So we can see it's the same one. Now let's try to change the owner. Let's say I want to change the owner to this one. I'll call change owner with this address. Now, so as I had said, to change the owner, you need to be the owner. And the owner initially was this address. Since I selected a different address, it's not letting me change the owner. So what I have to do is change back to the earlier address. And then I can see that the transaction goes through. Now, if I want to get the owner, I'll get the new owner. So these are some patterns that we use in Solidity. Obviously, there is a lot to learn when it comes to how Solidity is to be used. And what I have is mostly the entire thing that Solidity offers as feature set in these contracts that I've built over time. The the other two things that I want to talk about before I jump into actual uh, uh, using of the contract, which is what we had discussed earlier, is loops and mappings. So if you look at, the loops that are provided by the Solidity language, they're very similar to the loops that are there in JavaScript or any other language. So JavaScript is not strongly typed, so you'll see a var here that defines a variable, but rest of it is identical to JavaScript or TypeScript, whichever you're familiar with. So there is a for loop, and then it allows for a while loop. But one thing that needs to be understood about loops and Solidity is that the complexity of the contract makes it more and more expensive to call that contract. So if your loop is, let's say, running for 20 times, then the chances are that it will become a very expensive contract to run, and we can test that. Let's say I want to test it inside if else. Now this is again running 10 times. Let's say I want to run this. Let's say I want to run it, let's say 100 times, and the while loop also 100 times. The balance that I have right now is 99.999. Let's see how much it costs. It's substantially less. I'm not sure if I ran the right one. Let's say I give it so it's going to take a good amount of time to run, and then it brings down my balance substantially. So having said that, it is important to ensure that in Solidity, your contracts are not too complicated because there is a transaction fee associated with each call. Now, the other small thing that I wanted to demonstrate before I start looking at the calling code is mappings. So mapping is an ability inside Solidity to use key value pairs, where there's a key that you can define the type of. So right here, there's a key called of the type address and a value, which would be any value that you want to associate with the key. And it is a collection. You can have as many keys and values as you want, limited by the memory constraint. So a mapping could have like the native key values. It could also have another mapping, nested mapping, where there is a key and the value is a map. You can also have a key and a struct value. So if you want to take a look at this, let's try to deploy the mapping. So to add a key value, you have to provide the key value. The key is an address. I think I had a couple of addresses I copied here. Let's say I pick this address. And the value can be an integer. I enter any integer. Now, if I want to see this value, just enter the key value. Sorry. And I can get the value here after entering in the key. It can also remove this. Now, if I try it, I'll not get any value. So maps and loops and addresses, maps, loops, and arrays, they are used very frequently to hold and process large amounts of data or collection of data. And it is the few constructs in Solidity that you'll be using in any important contract that you build. Having said that, I had spoken about the ability to build a cryptocurrency. We've talked about a smart contract template that can help you create your own cryptocurrency. So let's try to do that. It's a bit interesting to do. So the first thing that you want is to have the code of the contract that you can then modify. It's a standard code, and for creating that cryptocurrency, you just need to decide on 2 or 3 variables, and once you've done that, you can deploy that cryptocurrency and use it in 2-3 minutes. The easiest way to build it is using the OpenZeppelin library. When we talk about libraries, Solidity allows you to use third-party pre-built modules, just like any other language that has libraries or modules that can be reused in any one of your programs. Solidity has OpenZeppelin libraries, which are very frequently used for building templated contracts. So you can go to wizard.openzeppelin.com and it will help you create a very simple contract very easily. Now, this is a very, very simple contract code. Most of the code inside the contract is written in here. All you have to decide is what is the name of the token or cryptocurrency, and what should be its symbol. Symbol means like Bitcoin has symbol BTC, or Ethereum has symbol ETH. So let's say I want to create a cryptocurrency by the name of Pacific. Let me first copy this. I can make changes inside Remix. So I go back to Remix and I create a new token. Let me call it Pacific token. Now I paste this code here. All I have to first do is just rename it to the file, although it's not necessary, but it's a good idea to have the file name match the contract name. So let's call our token Pacific token, and let's give it a symbol or maybe PAFC. Now this is all that is needed, and you basically created your own Bitcoin. Now how do you deploy it? Let's deploy it on testnet so that it looks more formal. So we go back to our deployment view. Let me select MetaMask. So I'm going to select Kovan and then deselect MetaMask so that it gets the right address. Now all I have to do is to deploy this token. This token is ready to be deployed. Let's see where the contract is. This is the contract that's been deployed. And this is the address. Now if I copy this address and go to view tokens from here, this is a special feature to view all kinds of tokens. You can see that Pacific token has been deployed. Its symbol is there. And by default, it takes 18 decimal numbers. What I can do is I can import this token in MetaMask and transact with it. The way to do that is I go to assets. I click on import token. This is the token address, token symbol, and I have my token deployed. So now I can send this token to anyone. So with that, we basically taken a very high level overview of the capabilities of Solidity language as a smart contract development tool. What we will be doing now is we will be trying to call the contract. So by calling the contract, what we mean is till now we've been calling the contract from here. We drop this down and we have these functions available that we try to call and see the results of it. These are all the token functions that we create. We look at the symbol, you can get the symbol here. You want to look at the name, you can get the name here. Now we want to do the same thing, but not in Solidity, but in a browser or in an application that we build. To do that, we'll need the capability of a library called Web3.js. And we do that right after a very short water break that I have to take. So feel free to think about what we've just done, and I'll be back in about 4 to 5 minutes. Thank you so much.
All participants, stay connected. We will resume shortly as experts have some work to do. Do cooperate.
Sorry about the interruption. I'm back. So again, just taking a quick pause. Any questions about what we have done till now? Okay. So now what we'll try to do is we will build a client to a smart contract that we will deploy, or the one that we've already deployed in the past. To do that, we will use a JavaScript library. So I've already built it for another contract. It's a simple HTML file. Let me open this. Give me one moment. So this is the content of the HTML file. This is a very simple body of the file that actually is not doing much except creating this headline. The core thing is here, where we are importing a script called Web3. This script allows us to do a couple of things. It allows us to integrate with our signer and then sign transactions as contract transactions that basically allow us to call our contract. So this script is the first thing that you'll import in whichever project that you're doing. Once this script is available, to call this script, you will have to start with initializing an instance of Web3. So and Web3 instance basically expects the address of the node, which might be your Ganache address, or the Web3 provider that's injected in your browser, which is MetaMask. So either of these can be provided to it, just like we've seen two ways in which Remix can call the node. Just like that, there are two ways in which you can call the node defining an instance of Web3. So it needs this provider instance. And once you've defined the provider, you're basically ready to call any part of the provider. And what usually happens is the interface that um, is exposed by a blockchain node is in a format called JSON RPC. So when Remix calls the testnet using MetaMask, what MetaMask does is it calls um, a remote node which exposes a set of HTTP interfaces in the format of JSON RPC. And you can take a look at what the JSON RPC elements are by just a quick Google. So all of the functions that basically you might want to call on a node are exposed through this RPC interface. For example, let's say if you want to call what is the latest, you want to know what is the latest block number on the blockchain, you will call this function. It doesn't expect any parameters. And then if you want to know things like how many accounts are configured on the node, you'll call accounts. So this entire API set, and it's substantial in number, it is available for you to call and interact with the blockchain node. And you can do that from here because they basically provided a very easy way to do that. You can just provide a URI for the plugin or the node connectivity transport, and then it can help you call these different APIs. But we'll not do that here. We just open this to look at these specifications. Now, coming back to our client, our objective is to call a smart contract. And the first thing that we need to know to be able to do that is to call the smart contract by passing the address. So first thing is the address. The second thing is the ABI. Once you have the contract address and the contract ABI, then you will be able to call the smart contract. Give me one moment to set this up. So To be able to call this particular HTML page, I'll have to run it behind a server. To do that, I usually use Apache, but a shortcut to Apache is running a simple Python HTTP server, and it can run in any directory. And that directory can be accessed from the browser. So the name of the file is MetaMask. So it's got no UI. Most of the code is going to be analyzed from the console. All right. Let's see. So let's first deploy our storage contract using MetaMask. This will take a while to again appear. So we've got the contract here, still in the process of confirmation. So I got this address, I copy it here. The next thing I want is the updated ABI. So I get the ABI from here. I copy the API and update the older one. Now this ABI has retrieve and store functions. Now let's say I want to call store. So the way to call it is first to retrieve the accounts using the request account API that we had seen in the JSON RPC. And it can be called from Ethereum, which is going to be automatically injected as an object when we have the MetaMask plugin activated. So this will give us the accounts, all of the accounts that are configured. We want to pull the first account. And this is going to be our account, which we will use for calling the smart contract. And once this account is available for us, we will initiate our contract using the contract address and the ABI that we just copied. And then we'll call the store function using contract.methods. This contract is the handle that gives us the ability to call everything inside the contract, like functions, checking field variables, um, updating field variables, anything. So we will store a specific integer. Once we got the store call implemented here, we will send this store call passing in number one, the account, the gas price that we're willing to pay, the maximum amount of gas that we're willing to pay, and that's it. Once we are able to store, then we will call retrieve to check whether the store was successful. So to call retrieve, I don't have to pay any transaction fees, so I can just call it very simply like that. Now, let me call the store function like this. Let's go back here. We've done our implementation. See, I'm getting the same error. I don't know why I have this. Now let's look at our console. From is not authorized. Okay, I need the right key because I deployed from a different key, which I did not. Give me 1 second. Let me check what account am I getting in my logic. All right. Let me see if I have the contract deployed correctly. Which I do. Let me deploy the contract one more time. This will take a bit of time. We'll have to debug this error and not waste further time on this. So what we basically are intending to do is to call the smart contract from a browser instance, just something that basically we've done in the past numerous times, just that uh, let's see if I have another instance that I can use to demonstrate this. Just one moment. Let's see. So I have another contract deployed, which we can test with. So we'll take a look at this in some time. Let's try another thing that I had planned for today, which is to build our own blockchain. So to be able to do that, we need a software called Golang or Geth client for blockchains. And you can download it from the Ethereum's website. You just type Geth client, and you can go to their page. And there is a download sections, which has download links for all the platforms, Windows, Linux, Mac OS. I have downloaded the specific version for Linux. It unzips to a directory, and in that directory there is just one executable called Geth, and this executable essentially has everything. So I had mentioned earlier in the sessions that it's possible to build a very modular client where we basically can have transaction verification, smart contract execution, all of them in different modules. And it is also possible to build a monolithic client, which is doing everything, like trying to verify the signatures, trying to interact with the rest of the nodes on the blockchain, also having a module for mining. So all of that is inside this executable. And the command to run it has a lot of parameters. So what I've basically done is I've written down all the parameters that you need minimally to run your own blockchain. So the first thing that you have to do is export a path, because you want to execute that Geth client. Without any parameters, what the Geth client does is it connects with the mainnet and tries to download or synchronize the mainnet blockchain. So we can try to do that first. So I have not added any parameters. I've simply typed text Geth, and then what you'll notice is it's going to start off with some statements about what it's doing. The important ones are here. It's connecting to chain ID 1, which is the production chain ID. Then its enode is this, which is its public key. Every node has a public key. And then it is starting the synchronization process. So you'll see these import of headers and receipts happen very, very quickly as it discovers other nodes on the blockchain. Now, as it happens, this will take a long time, like 2 or 3 days for complete sync to happen. And the synchronized blockchain will be created in my home directory. I look at hidden files, you'll see a directory by the name of Ethereum, inside which you'll see the Geth directory, and the actual chain data getting stored is here. So as this synchronization process keeps happening, blockchain will get downloaded here. We'll see newer files getting created. So I'll stop the process because I will run out of disk space if I continue it. Now what I want to do is I want to run my own blockchain. And to be able to do that, what I will set up is a set of parameters or configurations that are going to tell Geth that we are setting up our own blockchain. Now, the first thing that I need to do is give it a name. So I've given it, and it doesn't really matter what name you give. Then the second flag indicates that I want this Geth node to be accessible using HTTP. HTTP is an interface that allows my web client or my Remix client to connect to it. Then I have to define a data directory. This data directory is the directory in which I will be storing my blockchain. So I will run this Geth node from a predefined directory hierarchy in which Geth will find that data directory. So I'll run it from here, and I've created node 3 as a subdirectory. And then the port, this is the port using which Geth will connect to other nodes on the network. Now this port is not necessary because I'm building my own blockchain. I don't want other nodes to synchronize with it. But if I had wanted that, then this port would have been useful. In fact, I can remove this port altogether and this will still continue to work. Next flag is node discover. What node discover does is it indicates to Geth that other nodes should not be able to discover it as a part of their ability to do a scan and see what other nodes are running. Then I have to give a network ID, which needs to be an ID that is unique. Any number from, I think, 0 to 62535 will work. If I build more nodes in my network, as in, let's say if I set up one Geth node on this machine, another Geth node on another system on my same LAN, then all of them will start connecting with each other. And that connectivity for this node could only be up till 5. So I can set what is the maximum number of pairs that this node can connect with. And then I will be, this console basically tells Geth that it will show all the logs on the command line. And then this unlock will unlock my account that I set up as a key store. So we've seen our accounts till now as private keys or MetaMask accounts. There is a third format in which we can keep our accounts, which is called a key store format. Key store is an encrypted file that basically retains my private key and my account and some crypto data. So I will use that key store file, which I've already built here, and I will drop it into my node directory from where it will find this key store file at 0 location, and it will unlock it. But for unlocking, it will need the password to this key store file, which I have recorded in this password file. Then it will allow an unsecure lock. This flag tells Geth that this account should be unlocked forever till the time Geth is running. This is not a secure way to deal with it, but it's good for testing. And once I set this up, if I don't set it up, Geth will relock my account and ask for the password, I think after every 2 or 3 minutes. And then I have to define the HTTP port. So this could be, again, any port which is not non-conflicting with standard ports. So let me run this command. Now what I've already done is I've taken this key store file and I dropped it in here. But what let's do is let's start from scratch. Let's delete everything in node 3, which is my data directory. And then let's run this command from here. So first thing I have to do is to export my path variable to let Linux know where my geth is. And then I have to create a Genesis block. Since this is the first, this is my own blockchain. It's like me starting the number of blocks from 0. So I have to create a Genesis block. And I will put this Genesis block in the node 3 directory using the get command data dir node 3, which will tell where Genesis block needs to be. Init tells geth that the block has to be initialized using this configuration. So genesis.json is a configuration file. I've put it here. In this configuration file, there is some basic configuration about the blockchain. So we can ignore most of it. The most important one is this one. This allocates to this account this much balance, which means the moment my blockchain starts, this account will start having a huge amount of funds. Now, the very fact that it is my blockchain, I'm free to do that. So let's try to run the Genesis block command and see what happens. It will automatically do some configurations and write the Genesis state in my node 3 directory. So I had removed everything from node 3 directory. It created this geth directory with the Genesis block data. And then it created this key store directory in which it's asking me to put my key store file. I put my key store file here. Now I'm ready to run this. Now what you see is again a set of outputs. The most important ones are that it has been able to start my blockchain. And this error can be ignored. It's more of a warning because it's saying that it's not found an existing database of the blockchain, which means it will create its own. And then it's found this address, which is my basic address in which all the rewards will be credited if I start mining. There's no point mining because we're basically running our own blockchain. Having said that, now my blockchain is ready to be used. And the simplest way to use it is by connecting MetaMask to it. So I can go to MetaMask and I can add this blockchain. So the way to add this blockchain would be to define a new network. So I click on add network and I give this network a name. Let's say it's on 88457. The RPC URL for me is localhost followed by this port. My chain ID is this one, or maybe it'll be a different one. Let's see. This one. So now my blockchain is connected to MetaMask. One thing that I can do is I can use this key store file inside MetaMask, and I can see the balance that blockchain has given me. To do that, I hit on import account. I click JSON file. Now this JSON file is the format which is in which my key store files are stored. And I select browse and I go to my key store file. Now it is asking for a password. The password for my key store file is here. This will take a while because it's decrypting the key store. My browser might have hung. I'm not sure if you guys can hear me. I crashed my page. What I do is I'll import it using the private key, for which I'll have to get the private key. There is a shortcut to do that. So this is another tool called MyEtherWallet. It can be used offline, like I'm using it right now, to get the private key of my key store. So this is my private key. Let me import it in MetaMask again. Now let me import this account to see my balance. Now instead of key store, I'll use my private key. And as you can see, I have so much balance because I'm connecting to my local blockchain. So with that, we basically come to the end of what we wanted to discuss today. I'll spend 5 minutes tomorrow to go over the Web3.js code that was not working today. I'll try to debug it tonight and get it working. So any questions, thoughts, comments? Okay, I have. Okay, so again, not a lot of interaction. I know that it might be something new, and because of the scope that we have, I had to run over some things fast. But please feel free to talk about any section module that you feel needs more elaboration, or any point that you want to discuss. Usually in trainings, I have constant interruptions, which is why I usually keep a lot of buffer. Interruptions in the sense, in a positive sense, where people ask a lot of questions. So I I'm able to finish everything quickly, which is good. But at the same time, I would really like for this to be useful to you. So if you have inputs, questions, anything to say about the content, feel free to do that.
So there is a one question.
Yeah.
There is in a chat box.
Okay. Let me share with you a document, and this is a public document for Hyperledger. I created it for my trainings. Sorry. So Hyperledger is a little complicated to deploy, which is why it takes a while to kind of get everything working. And the problem with Hyperledger is that it needs to be deployed before you start using it. There is no testnet, or there is no Ganache tool that you can use for building your own Hyperledger instance without any deployment. So I've created this document. You all can access this document. It's publicly available. In this, I have all the links that you need to know, that you need to go to start your deployment, and then to actually test your entire deployment. All the commands are listed out here. And there is an analysis part as well, which analyzes the scripts that have to be run to build a very simple network and get your chain code deployed on it. And then also an ability to customize that network. So it's a comprehensive document that I built over the period of 4 or 5 trainings. And then it has a section on Explorer, which is a tool that lets you view your Hyperledger instance and look at the transactions and everything. So feel free to look at this as a reference tool to quickly get up and running on Hyperledger. But one thing that needs to be understood is that for Hyperledger, a good starting point is to learn about Docker and shell scripts. And then once you know fairly, or you're fairly familiar with them, you can you'll have to provision a Linux machine. Hyperledger works with Windows, but it's a little complicated. So having said that, this is a good starting point for anyone who wants to start from 0 to 1 for Hyperledger. Any other questions?
Thank you very much, Yash sir, for sharing your knowledge with us.
Sure, no problem.
We wish that it will be helpful to the participants in the area of blockchain to do more research on it. Thank you very much, sir.
Thank you. See you all tomorrow.
Yes, sir, for sure.
Thank you.
Now we are moving towards our second session that is conducted by Dr. Sudip Tanwar, sir. Good morning, sir.
Good morning. Good morning.
Sir, over to you.
Yeah, just a minute.
Thank you, sir.
Let me just share my screen.
Sure, sir.
I believe that my screen is visible to all of you.
Yes, sir. It is visible.
Perfect. So let me make it as a full screen and let me open the pointer also. So a very good morning to all of you. And I believe that this workshop is going to be a kind of a great learning for all of you. You have learned a lot about blockchain technology since its inception, architectural point, consensus and all. So as you know that I have already taken 3 sessions in this particular workshop, and there in this session we have covered fundamentals of blockchain, consensus mechanism, and smart contract implementation in the 3 sessions. And we have seen the implementation aspects of all these terminologies, whatever we have discussed in these 3 sessions. So what is the agenda for this particular session? So in this particular session, we will see that what are the current research trends and what are the key challenges in implementing the blockchain technology. These two are very, very important part, because let's say if you know what is blockchain and how to implement blockchain and what are the applications, then the next question comes that how I am going to implement it and how I am going to adopt the blockchain in the different applications. Okay, so we are going to discuss the agenda for this particular session is we are focusing on these two parts. The first one is the recent research trends in the area of blockchain technology, and at the same time, if you want to adopt the blockchain in different verticals, then what are the key challenges? So by considering these key challenges or by highlighting these key challenges, I will discuss the Government of India vision also, that in their document, what are the challenges that Government of India has already highlighted, considering the scenario of our India nation as a complete nation, not focusing on a particular state or a particular territory. So this entire presentation, I can say that in the next 1.5 hours, I'm going to share a couple of case studies with all of you and we will analyze that how the blockchain is going to contribute in the different case studies, or you can say different use cases. And we are also discussing about the key challenges. Okay, so we will see that up to how much extent we will cover in this 1.5 hour, because I have included I believe that 8 to 10 case studies, but I believe that in the span of 1.5 hours, we will be covering only 4 to 5 case studies. But we will try to complete as much as possible. And I will skip if the time is not with us, because we have to wind up by 1. Then I will skip some of the slides and directly highlighting that how the blockchain is going to contribute in any case study. So the first application that we are going to select for demonstrating the adoption of blockchain is the public sector. So how public sector means your government services, let's say midday meal or your birth certificate, your caste certificate, any pension scheme. That means all the services provided to the citizens from the Government of India side or from the government of state government side. And that's the way in general we can call it as a how the blockchain is going to contribute to the public sector. So in the first case, we will see what are the aspects that need to be taken care. And you all agree with me that particularly in the area of government, we can say that it's a very heterogeneous environment and very diversified environment also. Why? Because government is going to provide the services to the n number of stakeholders, like elderly age patients also, like students also. So the structure of government is like that. In the government, you have some students like your higher education, your primary education, your middle education, or your professional education. You have the teachers also. And apart from that, you have some accrediting agencies like NBA, NEC also. They want to, this is just a prototype, or I can say this is just with this particular diagram, I want to highlight that what about the heterogeneity, or you can say the diversity in the services of the government with respect to very specific application. Here we have considered educational sector only. So like the same way, you can consider any of the sector under the umbrella of the government services. Okay. So in this particular example, you can say these many stakeholders are there, and all these stakeholders need to be connected, not using a centralized system, because in the centralized system, we have already observed a couple of disadvantages like single point of failure or a single point of contact is there. So instead of that, we need to make a kind of a distributed ledger where all the stakeholders or all the part of the network, let's say these all are the part of the network, and this is your blockchain network. So all these are connected to a blockchain. Okay, so this is a very fruitful area where you can contribute to the government, and government is looking for a lot of funding from the research community, that some kind of proof of concept you can give to the government. Okay, so now under the umbrella of government, that how this blockchain is going to contribute, I will consider very realistic examples while I am discussing these applications, because then only you understand the technical depth of each and every use case that I am going to cover with all of you. So let's say, for example, in a government sector, you know it very well that we are having multiple organizations and multiple institutions. And these multiple organizations and multiple institutions, they are controlled by a authoritative domain. Let's say, for example, your education department is taken care by the Secretary of Education and Minister of Education. Like in the same way, every department is having their own ministry, and that we can call it as an authoritative domain. And these authoritative domain, they want to share some kind of data and some kind of information. Let's say CBSE want to share some kind of information or some kind of data to the n number of schools located in the territory of Gujarat, or not only in Gujarat but entire pan India. Okay, so this is going to be how they are going to manage this. So this information needs to be validated, needs to be audited, or you want certain level of security on the top of the shared data, which if I take an example, CBSE want to share. So CBSE at the same time want to ensure that who is going to maintain the security of the data that I'm going to share with n number of schools located across pan India. So as an example, if I consider a very specific example, let's say you want to send an email over a network, then you are not bothered whether the person live in US, Canada, UK, or across the globe. You are not worried about the location. What you are worried? You are worried about the email ID, whether the email ID of the person, respective person, is correct or not. Okay, so in this particular scenario, we can say that the whole architecture that is to be used in order to send email from your side as a sender to the recipient side who is located geographically far from your place, you have a central control like email platform. Like if, let's say, for example, I want to use the Gmail services, my account is there on the Gmail, then I am using the Gmail server in order to send email from my account to the person located far from my place. So which can talk. So this is the way how both the user can communicate with each other, and their communication is not dependent on the border of a specific country. If I am using or if I am considering the application of email, all of you agree with me. Okay, so this is a normal constraint. I can say that you are not worried while sending the email that whether the person is living in which part across the globe, but you are more worried about the correctness of that particular email. So now, on the other hand, let's say, for example, forget about email. Let's say I convert my conversation to the postal system, Indian postal system. Okay, so let's say you want to send one email to one of your friends, and you are living in a small village of India. Let's say, for example, you are living in one of the village of Amreli, district Amreli. Okay, and you want to send that particular postal, whether it's going to be a kind of a document or whatever you want to send, it's a postal email basically. Okay, and you are living in a Amreli village of Gujarat, India, very small village, and you want to send it to one of your friend, and your friend is also living in one of the small village in Canada. Then this type of scenario will be handled by at least two different government of India postal system department, government of Canada, Canadian postal system. So Indian Post and Canadian Post both are the parties. Okay, I'm taking a very realistic scenario so that you understand the technical depth. So when multiple organizations handling the same asset, what is the same asset here? Same asset is your postal email. Okay, so if the multiple organizations like Indian Post and the Canadian Post, they are handling some kind of asset together, then the problem comes that you need to develop the trust on the other party for the required information. So what is the meaning of that? That means, let's say I have sent one parcel from India to Canada, and I am using the Indian Post Office. Okay, So if I am using the Indian Post Office, then Indian Post Office has provided me a kind of a encoded ID or a kind of a code which I enter into their portal, and I can track the progress of my parcel, where my parcel is right now. But whenever your parcel is moving from India to Canada, then whatever information is displayed by the Indian Post Office, whenever your parcel is going out of India, then whether it reaches to the Canadian side or not, it is solely dependent on what? It is solely dependent on the services or the information provided by the Canadian Post. So that means if your parcel or your post gets lost at Canada for whatever be the reason, then you are at India, then you cannot directly blame the Canadian Post. Why? Because Canadian Post, you are not directly dealing with the Canadian Post. The Indian Post Office is dealing with the Canadian Post Department, or you do not have any way to verify at what location the post or the parcel gets stolen. You cannot verify. Why? Because you only rely on the information that is provided by the Indian Post Office and to the Indian Post Office by the Canadian Post Office. Whenever you are, it's a country specific, country to country, basically a kind of a transaction related to the postal system. So there is a requirement in this particular scenario, there is a requirement to establish the trust relationship. Why? Because our Indian Post Office is solely dependent on the information provided by the Canadian Post Office related to the issue or related to the scenario if our post gets lost at Canada. Then we are solely relying on the information provided by the Canadian Post Office. So that's the way there is a requirement to establish the trust among the two governments. So how can you establish the trust? How can you establish the trust in this particular environment when, if we take this particular as an example? So this postal delivery works good in a practical environment because these individual postal agencies, they completely trust on each other. When it comes to Indian Postal Department or when it comes to the Canadian Post Department. But there is a certain level of trust that if I am delivering a post from Indian Post to the Canadian Post, then the other end is equally responsible to deliver the post or parcel to the final destination. That means whenever Indian Postal Department will hand over the post to the or parcel to the Canadian Postal Department, then it is the sole responsibility of the Canadian Postal Department to deliver this to the destination address located at a far village available or one of the small village located at Canada. This is one of the problems. Second problem, difference of rules. When it comes to Indian Postal Department, they are governed by the Government of India. When it comes to Canadian government, Canadian Postal Department, then it is governed by the Canadian government. So that means there are different rules of negotiation, different rules of operational. So if you bring them to a common platform, then it becomes very difficult because proving faulty party is sometimes very difficult due to the non-access of global data, where Canadian government is not giving the access of their data to the Indian government, Indian government is not giving the access to the data to the Canadian government. And why this access of data is so important? Can anyone tell me in the chat window so that it is going to be a more interactive session? See, these use cases I have prepared in such a way that will give you a kind of a practical exposure that it is not very easy to apply the blockchain directly to any vertical or any application. First, you have to analyze that particular application very carefully, number one. Number two, you have to analyze, find out the problems in the application, and then only you can see that what part the blockchain is going to solve and what part this blockchain is not going to solve. Now I come back to my question. In this particular scenario, why it is this known access of global data is so important? Why? Can anyone tell me that why this known access or access to the global data is very, very important for all the stakeholders? Can anyone please tell me? Because in the blockchain, you have already noticed that it's a distributed ledger technology, and every individual is having the copy of the ledger, whether it's a Canadian government or whether it's a Indian government. So now the next question comes, how they are going to tackle this data. Okay, so these two problems that we have encountered, the first is the different rules of negotiation, and the second problem that we have identified is the trust relationship. So these two problems are the motivation for adopting the blockchain in this defined scenario, considering these two problems. So from the government perspective, government needs to maintain multiple assets all together, like asset in the form of digital or sometimes asset in the form of printed also. What is the meaning of this digital? Sometimes you want to send some kind of amount from your account to your friend account using the postal system, or you want to send, let's say for example, some kind of parcel that is in the form of hard copy available from Indian Postal Department to the Canadian Postal Department. So this is the motivation. Now we will see how these two problems can be taken care by the blockchain technology and what aspect this blockchain technology is going to solve in this particular. So government needs to maintain what? Government need to maintain the document both in the form of digital or paper form. So they need to maintain their daily operations and activity, how many parcels are delivered, how many are received, whether they are reached to the recipient from the Dakia side or not. So many activities that the postal department need to take care. If I take an example, government assets can be in the form of land record, in the form of building information pertaining to the healthcare. If we are not restricting only to the postal example that we have considered in our previous slide, and government need to maintain the detail of citizens, organizations and institutions also in this particular case, and they need to maintain the record of the citizens also, that how many types of citizens are there, what is the age of citizen, if they need any specific information to start any special drive for any elderly age patient, and basic kind of transactions that related to the record or related to the finance. So these are some of the activities that I have included here that government need to maintain, and all these activities need to be captured in the form of any ledger, and that ledger we can call it as a distributed ledger. Now here you are having two options. You can use the centralized ledger or you can use the distributed ledger. We are not using the centralized ledger. Why? Because we have already considered a lot of issues related to the centralized ledger. It creates a kind of a monopoly, dependability. So that's the way this distributed ledger is a best option to be used in order to maintain all these records at the end of the government. Now we will see how you will keep these record of transactions. So record of transactions we have already categorized, or we have given already the example. Now I will tell you that how will you keep the record of the transaction. So if you want to keep the record of transaction, then you have two options. Either you can keep them in the form of paper. Let's say you go to any postal department located at a far village in India. They are using still a kind of a register, okay, and they are not connected to the internet. They don't have very limited access, very far located village postal office, okay, or post office. So now in that particular case, they are maintaining the register and they are sending it to the head office, and on the head at the head office, some other person is doing this kind of entry. So if you keep all the information, all the transactions in a paper, then it is always vulnerable. Why it is always vulnerable? Because there are chances of any theft, number one. There are chances of any kind of damage to that particular document containing in a register or in a particular file. So if you keep them in a digital format, then who is going to host the particular information? So if you visit any Tehsil office nowadays in India, most of the states, they have already started this process that all the registry department documents, whether it's a sajra or it's a map or it's a sale deed, all are now converted into a digital form. Okay, now all things are converted into a digital form. Then who is going to take the ownership? This is going to be a big problem, big problem. Whether the Tehsildar is going to take the ownership, DM is going to take the ownership, who is going to take the ownership? And why this ownership is so important? Because in case of any issue will arise, theft of data or some kind of attack, then who is responsible? So that means this is going to be a big challenge. So now, for example, For example, let's say, for example, if the Indian government has business relationship like with Walmart, if I take a very realistic example, let's say Indian government is having some kind of business relationship with Walmart, and you know that Walmart is a private agency, then this transaction information who is going to maintain? Whether the Walmart is going to maintain all the information, if it is a joint venture between the Walmart and government of Gujarat or government of India, then who is going to maintain the transaction information? Choice number one, option one, government is maintaining his own part of transaction and Walmart is maintaining his own part of transaction. That means whatever transactions are initiated at the government side, government is going to take the responsibility. Whatever transactions are going to take care, going to be initiated from the Walmart side, the Walmart is going to take the responsibility. But this is not the way the problem is solved. Problem is still there. What are the problem? Let's say if certain dispute will come, then that dispute needs to be resolved by the auditor. That means the third party or the lawmakers, or that will go to the court. Okay. Then you know it very well that when any dispute will go to the court, then it will take years to resolve, because proving something wrong has happened not only in Indian context but across the globe. In some of the country it is very difficult and it's a time consuming process, and in a multi-organizational environment it is very tough sometimes. Multi-organization means government, Walmart, or so many other private agencies are there. So when the information is distributed among the different stakeholders, then proving wrong, that who is wrong, is sometimes very typical. And to make this final judgment at the end of the court, which is a third party, you need to rely on the facts and the proof that you as a party have submitted to the court. So if you want to store all the information to a central data store in which both the government and Walmart can insert their own transaction. Okay, so that means if you are maintaining a kind of a database, choice is yours, whether you want to use a kind of a central database or you want to make it kind of a distributed database. So where it is not only that government is storing their data on their server and Walmart is storing their transaction on their server. No, we have a common server, and this is a blockchain server, let's say, for example, and every transaction will stored on this particular server, whether it come from the government side or it come from the Walmart side. Now, in this particular case, but the problem with this architecture is still there. What are the problems with using this centralized database? If I'm using the centralized database, then first one is the cost, because you need to pay more money to the third party. Let's say if you are using the centralized approach, then let's say you are using the services of Microsoft Azure. Okay, then in order to maintain your data, you need some kind of storage. Okay, and that storage you have taken from the third party like Microsoft Azure. You have purchased some cloud storage. So that means you need to pay. Second problem is you need to rely on the services provided by the third party. So let's say it is just like that. If the cloud hosting platform crashes, your Microsoft Azure is not providing some kind of services for the next 6 hours or 60 minutes, then all the transactions are nowhere, or you cannot validate the correctness of the transaction or of a recovered transaction. That is the second problem. So these problems are related with the central or the state government. They are facing these type of problem in their day-to-day work. So how the blockchain is going to contribute here? So blockchain can provide a ubiquitous platform. What is the meaning of this ubiquitous platform? It's a 24/7 anywhere platform. It is not only placed on a kind of a, let's say, located at Gandhinagar, or not to be transferred or not to be accessed to one of the district of Amreli, like, or any other district of like Surat. So over this architecture, we can build up a kind of a relationship among the multiple organizations all together. In a couple of few slides, we will see in the next few slides that some of the use cases, how it can be done, because very broadly we have described here, or we have already highlighted that how the blockchain is going to contribute here. But you have a couple of questions that what part of the blockchain is going to solve and what part the blockchain is not going to solve. So certain aspect, let me just we will take. Now, you see country like India, we have a different states. Okay, we will start from a country, then country to state, then state to district, and district to villages and panchayats or village panchayat. So complexity is more. It's a multi-institutional or multi-organizational environment, not only in India but across the globe. For in most of the countries, whenever any information is disseminated from the central government side, and how it is reaches to the end user, it has to be passed from the different phases. So now how will you ensure that whatever information in a right way is conveyed to the state, state to district, district to village panchayat, or from village panchayat to the end user? It's a very diversified and heterogeneous environment. So in this particular environment, they need, or in particularly in a multi-institutional environment, they need a kind of a platform which will help them, or where all the district headquarter, panchayat, village, your state team, or your central government, all these are connected to a single platform, and this single platform will be responsible to do everything. And anyone as a party, like let's say DM want to have some kind of information, so no need to contact to anything, all things are available here. He is authorized to access this particular platform at any time, depending upon the access right given to an individual. Okay, so this is the heterogeneity or a actual fact that is not only within India but across the globe also. So in this multi-institutional or multi-organizational environment, every level build its own ledger of data. So let's say state is maintaining their own data, village panchayat is maintaining their own data, central government is maintaining their own data, state government having their own policy, central government is having their own policy. That means different access management policies are there, or role-based access control or access management is there, or different priority of data. Let's say sometime you need to give high priority to any particular specific application of data. Let's say if I take an example, let's say in case of Aadhaar, so it's a very sensitive data. Okay, in the recent past also, you have already seen this news in the news channels or in the newspaper also, that for certain user the data related to the Aadhaar data is leaked. So that's the way every government is having different priority when it comes to securing and providing the privacy to the data. If you take an example like Aadhaar, which you want to prevent to be accessed by the unauthorized person or unauthorized individuals. So now how the blockchain can help in managing the government services, because in our previous slides we have mentioned that we have already discussed that what are the services that government is going to provide at different level. So you know it very well that what is the structure of the blockchain. In the blockchain we are having different blocks. Okay, and different blocks are connected with each other, where the next block will store the hash of the previous block. Okay, and this is a complete single blockchain. If I take an example, so here the block can contain huge amount of data, every individual block, and this data cannot be altered without the majority of the block agree to that. That means the consensus comes into the picture, and data can be accessed as a transaction, and anyone can check, verify who has accessed the transaction. Let's say any DM has accessed the transaction, so we can fetch the log for that particular accessing of data at any instant of time, because everything is available on the blockchain. So this is the way how blockchain you can assign. Let's say for example, you can create a separate blockchain for states, or you can assign all the states for a common services. You can create a single blockchain for a specific application number 1, specific blockchain for application number 2. So that is the choice by the government side, whatever option government want to adopt. But I will tell you here a very simple and very interesting thing, that nowadays, not only in India but across the globe, people are facing a challenge that we have maintained a distributed ledger. Now there are so many cyber attacks on the distributed ledger, where people want to get the access of the data, access related to the citizens of data, access related to be the healthcare related data, or they want a kind of access. So this is going to be a very, very typical problem, how to maintain the security and privacy of this data. So this data that is a very huge data, not only related to any specific information, but it contains all holistic information of a individual citizen or any. So I will tell you some interesting examples now where it's going to be a kind of a cyber war nowadays, where these cyber attackers, they are technically competent to attack the government services relate because their intention is not right. They want to get the access. Like in the day before yesterday, you have already seen that between there is a situation of war between Russia, okay, so in this and Ukraine. So you have already heard this news that there was already a cyber attack launched from the Russia side on the data of Ukraine, citizen data on Ukraine. So like in the recent past, you have already seen that there was one news that Facebook data gets leaked. So how can you identify or how can you verify the news that is coming to you, whether it is a fake news or not? Because if you see this particular news that Facebook data shared with some third party agency, so although it is very difficult to validate the correctness of such news, because why? Because the reason is very simple, that there is no such log available on Google or freely where you can see that these are the logs of Facebook, and after seeing these logs you can see that these are the instances or these informations are already shared, already leaked. So it is very difficult actually to say that it actually happened or not. To analyze that particular log, you need to have a strong team of cyber security experts which can look into the committed transactions, and looking at the committed transactions, those are there inside the ledger. You can visualize that how many different transactions are already occurred, who has performed the access, what kind of access they have performed, what kind of data they have stored, or different data transfer happened over the internet. You can visualize. That means there is a huge demand in the times to come from the not only from the computer science field, but it is an interdisciplinary field. Basically, cyber security professionals, lot of demand rise in the times to come, where the companies are looking for the cyber security professional, because every company nowadays have a dedicated cyber cell whose responsibility is that their server is not to be hacked by the third party or by someone else or the attacker. What kind of preventions or what kind of measures you need to take, you please take care. But this thing will never happen in with respect to our server. So this is the area, certain slide I am just keeping, because let's say, for example, if I consider how the government is processing the data. So data is shared among multiple organizations at the different level of government structure. I will take a very simple example. Let's say the problem of data breach increases at every level. Why the problem of data breach increases every level at present? Because let's say I want to take Geo connection or I want to take a BSNL connection. There I need to submit the hard copy of my Aadhaar card. Then again, I want to open Punjab National Bank account in Punjab National Bank. Just take an example. You need to again give your PAN card, Xerox, and your Aadhaar card. Why there is a requirement to give again and again the same document? Why there is a requirement? If you are giving the same document Xerox or in the soft copy to someone else, maybe in the recent past, you have already observed that there are a lot of frauds where someone has taken a SIM card on your name and they are using it and they have carried out already one kind of wrong activity, and you are a kind of a suspect for that. So that means the data duplication and multiplicity, these two are the very genuine problem that needs to be taken care. And these are the recent challenges basically. So if you are submitting the copy of your Aadhaar card to some bank or some mobile company, then you are actually making the duplication of the data. So how to stop this duplication of the data? This blockchain is going to provide you a support, a kind of a framework where everyone is having the digital locker, and inside the digital locker, it's a distributed ledger, and you need to store all kind of your credentials, and all these needs to be, if someone want to access it, then you need to just give the hash of your distributed ledger or then ultimately the recipient side will try to fetch all the related data. So these are some of the recent challenges that the government is nowadays facing. So now another use case that I want to highlight under the umbrella of the government is the passport data. So we know it very well that let's say if I want to have my new passport, I want to visit to the regional passport office located in a particular 2 to 3 locations in a particular state or more than that. Okay, and then you need to submit certain data and your passport will be reached to you within a limited time period that is prescribed by the government and the third party service provider like TCS is providing, if I take an example. So have you analyzed your passport data is not only available with your regional passport office or with the government, but your passport data is given to so many agencies. When you are traveling from India to US or Ukraine or Russia or any China or any other country, how they are going to verify that you are the right person or you are the legitimate person? So let's say if we take a very realistic example, then we will see that what is the challenges in this particular use case. This is your passport data. So let's say this passport data contains all the data of all citizens of India, those who have already their passport available with them. So that means Ministry of Foreign Affairs manage the passport data management of all the citizens pertaining to the country. Now, the other agencies also have the passport data. So let's say your airport and seaport or custom check department, they are having your access to their passport data, access to your passport data. They can review it, and depending upon their review, they can allow you to enter or they can deny give the permission to deport you also. This is one individual entity, those are having the access to your data. Then there is in the income tax department also, there is one periodic check, how many times you have visited to so many countries, and the National Intelligence, National Audit Agency, they are maintaining a kind of a regular check on your passport data. After that, your National Army Defense Agency, like in India, we are having NSA, so National Security Agency. So this agency is also having the access to your passport data. So they can see that how many countries you have visited and how many days stays you have already performed in a particular country. Or your CBI or CID or any crime department or police department, National Police Agency, they also have the access to your passport data. Why? For what purpose? Because their intention is they want to do some kind of investigation. After that, your Ministry of Public Services also maintaining the access to your passport data. Why? Because they want to maintain a kind of identity database. I have included only few examples here. This list is very long. Now the big question is, what is the big concern here? The big concern is, if the other agencies also have the access of your passport data, and let's say, for example, if something wrong happened with your passport data, then who is going to take the responsibility out of the so many stakeholders? Then verifying that at what end the mistake was taken, it is very difficult to prove. Then, because it's a centralized system, then the blockchain technology comes into the picture, because if all these are over a single platform and everyone can see that what is going on in the network, who has access, how much amount of data, what is the log, and if you encounter any red flag you have raised against a particular individual, that is also visible to all, and there is less scope available for the attacker to attack, because all the data is stored in the form of hash. Basically, looking at the instances, you cannot visualize, it's a mapping by not by name, not by passport number. Also against each and every, we have stored the data in an encrypted form, and on the top of, we have used the hashes in the blockchain in order to preserve the privacy of the individual. But we will see how this is going to be taken care by the adoption of blockchain. So you can consider this slide as without blockchain. Now in the next part, we will see how the blockchain is going to solve it. So let's say you are having a kind of in this scenario, in this particular PPT, we are considering how the blockchain is going to tackle the challenges which we have highlighted in the previous slide. So if you have a service requester, okay, so let's say in a scenario, you are having a service requester which is a person through which you can place your request, and which request the service requester will request the service from the data collector through some service broker. So let's say these are the service broker who help. And what is the role of service broker? Service broker can help you to get the access of the data. So it is not directly one-to-one, but it is through some mediatory, not exactly the mediatory, but it is, for example, let's say in case of Aadhaar, your UADI is responsible as a service broker. If I take a very realistic example, if you want to access the data of Aadhaar of any individual, then the agency UADI comes into the picture, which is responsible in order to maintain it. So that means we can consider this UADI is as an example of service broker. So if the service requester request any data, then that data will pass through the service gateway. Okay, and then this request will reach to the service broker, and under the service broker we are having different functionalities. And then this is going to be a very secure scenario where everything is available on the blockchain, and if who has accessed the data, that information is also maintained, and everything is captured inside the log, and that is maintained in the distributed ledger. So this is the way how the blockchain is going to solve. In a very abstractive way, we are discussing right now that how blockchain is going to contribute in this particular example. Now, how the blockchain is going to help, what is the gist of this particular slide? First advantage is the access and verification of central data. Whatever data is stored at a server, you can have the access and verification you can do very easily. That means data is in a database. It is up to you. You want to use the central database or a distributed database. Access to the database are the transactions, whether it's going to be kind of a digital transaction. Every such transaction, that means the access to the data is locked in a blockchain. That means whosoever want to access the data related to the database, available in the database, whenever any fetching is there in the database, then that information is to be stored in the blockchain. That means directly you cannot access. If you want to access it, that means the information will be stored in a blockchain. That means the data can be accessed only through the blockchain. There is no way available that you can access the data directly. Why? Because if you access the data directly, then who is going to be the regulatory? Because it's going to be a kind of end-to-end transaction, then who is going to take the ownership? So here, if you are making this kind of system that data is to be accessed through the blockchain, then you are creating a kind of a ownership. Okay, so anyone can verify if you are doing this kind of practice, then who has accessed the data at what timestamp and exactly for what purpose they have accessed the data and what kind of attribute they have accessed. Like in a particular module of your passport, there are 7 modules. If I take an example, like country visit, or like how many shops you have visited, how many times you have used your credit card, your debit card, international credit card. So if I'm interested to only see that how many times you have used your credit card, at what locations you have used it, because I want to do a kind of a reverse engineering. Okay, I want to check that how many stores you have visited and how much amount you have spent and what kind of material or the items you have purchased. Okay, something like that. So this is the first advantage if you are adopting the blockchain in this particular passport data management system. Second one is the sharing of data. That means instead of putting the access in the form of transaction in the blockchain, you have to put the data in the blockchain itself. There, if you see the recent trend nowadays, researchers are using the off-chain based mechanisms, off-chain based storage, because there are 2 types of mechanisms are available through which you can store the data to the blockchain. One is the on-chain storage and second one is the off-chain storage. That means in case of on-chain, you need to store the entire data onto the blockchain. But in case of off-chain, you need to store, no need to store the entire data onto the blockchain, but you need to store the hash of that particular transaction or that particular block, and through the hash you can fetch it. Okay, so this is the second reason. Third reason is sharing of data and access control. That means it keep both the data and the access at the blockchain. So anyone can verify the data and access at any instant of time. Neither the data nor the access can be deleted, because we know that blockchain is an is an immutable ledger. So access cannot be denied. 24/7 bound to provide the services. If anyone want to access, then that access will be provided from the blockchain server. Okay. So these are a couple of the examples. Now in the next few slides, we will see not only with respect to the India, across the globe, what is the scenario, particularly in the government sector, how the different government have already adopted the blockchain and in what part they have adopted. This list is very long, but I have kept only few examples. Okay. So like if I take an example of Russia, the state-run Bank of Russia, they have already adopted the blockchain to implement the record document transfer and storage via blockchain. Okay, there was in 2017, they have already carried out this exercise. The first government blockchain they have already implemented for Russia. Now, if you take an example of South Korea, so there is one group, that is the Dayali Group, a house of Korean fintech startup. So they have already created the blockchain-based ecosystem, which they call it as a icon basically. And this icon platform allow the government departments of Korean government department, particularly not the North Korea, but the South Korea only. So South Korea government departments like universities or the various department, hospitals, banks, etc., to interact without any third-party network. That means they have established a single blockchain over which all the government sector companies or startup or all kind of stakeholders, they are connected. Okay, so they have already developed this entire blockchain setup. If you take an example of Singapore, very small country, the government has already initiated the project UBIN. So they call the project for adoption of blockchain in the government services as UBIN, which explore the use of distributed ledger technology for clearing and settlement of payment. Because you know it very well that, let's say I have submitted one check to the Punjab National Bank in my account, and check is from Punjab and the bank is State Bank of India. So for the clearance of the check, sometime it will take 2 to 3 days. And maybe if there are some wrong signature or there may be some typo mistake, then after 3-4 days, after 7 days, if your account is not credited, then you inquire to the bank. Then bank official will say that, hey, this is the problem, and for that particular reason, your amount is not credited to your account because of these reasons. Then you have to ask to the third party, please reissue the check again. So now this is the problem. Wrong settlement, number one. Delay in settlement, number two. Why? Because once you submit the check to the branch, to respective branch, you are not the party. You can only see whenever your account is credited. Till the time in between, you are not the party. Your check will go to what kind of various stages. So if you put all these information in the block in check clearing system, if you want to adopt the distributed ledger technology, then all the parties, including you also, all are the parties, all are the stakeholders. So this will reduce the chances of delay. This will reduce the wrong payment settlement also. So that is the reason why the Singapore government, they have already initiated this for the domestic interbank payments. So try to explore it also. If you take an example of India, India has already initiated various version of blockchain like Bharat blockchain. Okay, I will tell you at the last that what is the scenario in India. I will spend more time on the Indian context also, that how the different companies or our Indian government, they have already initiated the adopting the blockchain in the different verticals. So in India, a trial solution for utilizing the blockchain technology, particularly for the educational document verification, has already been taken as a pilot project by Government of India, India Chain, where no need to submit any document to any employer, and your verification will not be taken care by the third party, but that particular organization where you have grabbed the job, that particular organization can verify your entire educational certificate by their own, because all the things are available in a distributed ledger, and you just need to provide your hash to them, and through that encoded ID, they can fetch your entire information. It will save the paper also, but the challenge is how to provide the security and privacy to this huge amount of data for the country like India, having the population 130 crore plus. Okay, so now Like if you take an example of USA, also a lot of example in the USA where they have already applied the blockchain in order to manage their functioning of federal agencies, particularly in the area of financial management, procurement process. Because in US in the recent past, you also agree with me that a lot of bad practices people have used, particularly in the procurement process. Okay, so they want to adopt this particular blockchain technology in order to in order to reduce these chances of any fraud. So these are some of the use cases I have highlighted. So in the summary, I will tell you that how we have already discussed that the how government is utilizing the blockchain, particularly to secure the data as well as ensure the access and auditing of information at the government level, whether it's a state government or it's a center government. So now this is the end of use case number 1. And now we will take a very interesting use case, very recent use case, and then we will discuss what are the challenges that this use case is going to solve. In this particular application, I have selected 2 use cases. First, we are going to discuss taxation, very important use case. And second, we are going to discuss about digital land record. Okay. So now I will tell you first that what is the motivation of using these 2 use cases or discussing these 2 use cases. In the taxation, you have already noticed that GST is having very heterogeneity in performing or applying the GST. State GST, center GST, SGST, CGST, or different variety of goods. If you refer the document of GST issued by the government of India, then you need at least 3 to 4 days to read out it completely, and then also you understand only 10%. Then you have to revisit it number of times if you want to become the expert in GST. Okay, so this is the reason why we want to discuss that the GST use case. Second one is the land record management. Country like India, we in the recent past we have already observed that same flat, same plot sold by the broker or by the property dealer to multiple individuals. Okay, not only in Gujarat but across the globe, not only in India also but in some other part of the globe also. So that's the way how we need to build up, or there is a requirement to build up a decentralized distributed land record management system where no need to go to the court or tehsil office to get the Xerox copy of any sale deed. No need to go to the lawyer to take the services of lawyer to have the hard copy or something like that, some information related to the land. Or in nutshell, I will tell you how will you check the whether, let's say I am having a flat and you want to buy it. How will you check that this ownership remains to be with me right now, and what are the dues on the particular property? So these are some of the practical reasons why this blockchain comes into the picture. We will see that what part the blockchain is going to solve here. Okay. Now moving further, so you know that the first we are going to discuss about how the government is processing the tax payment. So like GST, you know that goods and service tax, it's an indirect tax covering various goods and services. It includes 2 components. First one is SGST, that is the state GST, and second one is the center GST, goods and service tax. So the entire workflow is pretty complex. Let's see how the blockchain can help in this particular segment. So now I will take a very simple example just to demonstrate you that what is the complexity of GST. So say you want to purchase a particular dress. So let's say as a user, my wife told me today that today is your birthday and I need to gift one shirt to you or one t-shirt to you. Then you feel yourself more happy that yes, so you entered into a particular mall or a particular shop. That means your intention is you want to buy or you want to purchase a dress. So now you want to purchase a dress directly from the shop or directly from a particular mall. Inside a particular mall, there is a particular shop or a particular showroom. Then have you analyzed that how many phases this dress has passed? That means since its inception and reaching to the shopkeeper, what are the different stages, and why These stages are so important because at each and every stage, the individual has already paid the tax. So that we will see. So it has multiple workflow at the production stages. So let's say as a user, you want to buy any shirt. So initially, the farmer needs to produce the cotton. So this is the farm where the farmer has already produced the cotton, and then this produced cotton comes to the vendor. Okay, and then you require other material also to produce the dress. Like this particular dress, if you want to purchase, then you need the needle, you need the thread, you need the colors, etc. At the end of the company, then the dress goes to the shopping mall, and from the shopping mall you purchase this dress. That means this is the stage number 1, stage number 2, 3, 4, 5, 6, 7, 8, 9, 10, up to n number of stages, and then it reaches to the shopkeeper, and then ultimately it reaches to you, and you have purchased it. Now, but how many government how the government apply the tax at different stages we have already discussed. On these different stages, although GST make this taxation process more governed, basically prior to GST there was not a completely governed system, but I can say that this is a good initiative from the government side, but still there are some flaws that the government of India also want to tackle. So now we are going to discuss that what are the flaws, and then we will discuss that how the blockchain is going to contribute or going to solve some of the part. So although the GST makes this taxation process more governed, but the entire stage is bit complicated. When the farmer is selling the raw cotton, they are providing certain tax to the government. It is just like that they need to go to the mandi, and there in the mandi also certain tax will be applicable to the farmer also. Okay, if you want to sell 2%, 1%, 1.5%, roughly some tax. So first instance where the farmer has paid the tax when the farmer want to sell the cotton. Okay, now then the production house which converting the raw material purchased from the trader to the cotton balls give certain taxes to the government also. This is the stage number 2, stage number 2 tax. And the same is the case with all other companies involved in the different stage, like company producing the needles, company producing the thread, company producing the ledger, or company producing the billing document, or something like that. This list is very long. That means at the interval stages, each and every individual has already paid the tax. So all these taxes added to the price of the dress. Yes, very much right. And at the time when you want to purchase a final dress, then the customer also pays the tax. So that means there are so many variations in the tax, and ultimately when you want to buy the dress, then also you have to pay the tax. So that means very much complexity is there. Okay, so now as per the GST rules recently issued from the government of India, entire tax is paid by the customer at the time of final purchase. So the intermediary tax paid will be refunded back to the corresponding production companies or also to the farmer. Listen it very carefully. Whenever you are buying as a customer, you are paying the final tax, and whatever be the intermediary tax paid by the intermediary companies, it is going to be refunded back from the government of India side as per the policy that they have defined. Now, this is a big question mark, how they are going to refund it. How they are going to refund it. For example, whenever company producing cotton, then selling the cotton to some dress stitching companies, then the tax which is already paid by cotton producing company, that will be refunded back to them, back to the cotton producing company, because the entire tax is on the customer side who will purchase the dress. Now the next question comes that how will the government will ensure that the tax is refunded back to the intermediary companies or not? So GST is applicable at every stage of production. Yes, it is very much evident from the example also. However, is refunded to all the parties in the chain other than the final customer or as an individual user when you are the end user. So now in India, you know that part we have already discussed. So now without blockchain, how the government is going to refund it. So now in this particular use case, we will discuss without blockchain. Right now, what the government is doing and how the government is refunded or refunding the the intermediary tax to the different organizations or the different companies, because ultimately the customer or the final end user will have to pay the tax. So now let's say, for example, consider this GST. Let's say whenever you want to purchase any particular dress or any particular item, then a GST invoice is issued by the seller to the customer. So buyer pay the bill with GST, okay, and then this information that buyer has paid this much amount of GST will be recorded in the GST portal. So let's say you have paid 20 rupees GST. So this information that person X visited this particular shop having this particular GST number has already paid 20 rupees GST. This information is captured, was recorded at the GST portal. Okay. So now the seller pay the tax to the supplier. Okay. And this information that the seller pays the tax to the supplier is also recorded in the GST portal. And the final tax goes to the government. So now this additional payment is adjusted. So how now the task of the government is what? Under this defined scenario, the task of the government is to make a huge calculation. What are these huge calculations? That which part of the GST is refunded back to the intermediaries of this production chain, and which final collected part is to be distributed among the central government and state government in what way? Number two. Number three, this entire exercise is carried out by the government employee. Who is the government employee? GST officer or a kind of an inspector. Okay, so that is going to take care this complete exercise with the help of some defined software, with the help of third party. Okay, so now there is a big question mark. Let's say, for example, in the recent past also we have observed a couple of examples where people have done some kind of blunder or cheating by giving some kind of money to the GST officer, and they are not giving the tax to the properly GST to the government. This is the reason number one, or I can say the issue in this particular defined scenario without blockchain, because government is not the party. Whatever is decision taken by the GST officer, that decision is final. That means your resilience or your dependability in this particular GST complete framework is more on the inspector or the GST officer. Although the GST officer is following the regulation prescribed by the government of India, but there are certain loopholes available which they can take it as an advantage, and they take some kind of money, black money from a particular production house or from other person also, just to give them some kind of flexibility not to deposit this GST. It's a huge loss to the government. Okay, so now we will see that how these complicated stages can be taken care by the blockchain. So now with the blockchain, if you want to apply the blockchain in the GST, then how you can apply? So the first step will remain same. A GST invoice is issued by the seller when you want to buy. So buyer pays the bill with GST. So whenever buyer pay the bill with GST, then the seller pay the tax to the supplier. And this is the beauty, and this is the step that blockchain is to take care. Okay, in the previous slide, after that we are having bit complicated informations, but all these informations need to be, all these intermediate steps need to be replaced by having a smart contract. That means whatever is prescribed by the government of India, depending upon that, you need to frame out the smart contract, a piece of code which is written in any programming language. And after that, whatever amount is refunded back to the intermediary, that is already there in the smart contract, and there is no human involvement, no GST officer or no inspector involvement in this particular case. Automatically, this smart contract calculate or adjust the tax calculation during the payment process, and whatever tax is calculated by this particular tiny program, that will go finally to the tax goes to the government. That means smart contract ultimately calculate the tax based on the set of codes. The tax engineer or the GST officer can help to frame out the smart contract only. So no need to involve government in every step, rather than in the production chain. The things are getting adjusted at each individual step based on the smart contract, and automatically without any human intervention, the required amount of GST is credited back to the account of the intermediary production houses. And this smart contract, you know it very well when we have discussed, these smart contracts are immutable. That means no one can delete any entry, no one can do any kind of forgery, because these are written in a specific manner, and if someone is doing it, then other parties are having the copy of this, and entire copy is available on the blockchain. So there is less scope available for any kind of cheating or any kind of bad practices. So this is the way how this GST problem is to be taken care with the blockchain. So now with the blockchain, during the payment process, how it is going to contribute or how it is going to tackle the problem. So during the payment for a good or service, blockchain smart contract can automatically calculate the invoice based on the tax amount that is already paid during the production process, and smart contract directly transfer the required amount of GST to the state or to the center. There is no need to do the calculation at the end of the GST officer, and the refund, if any, is directly paid to the customer account, because all these things are mentioned in the already defined smart contract, and everyone is having the distributed smart contract copy. Okay, so what are the advantages after adopting the blockchain in the GST? The administrative burden for accounting services is drastically reduced. Okay, so all the transactions are done in a real time, no return filing is required, or return filing can be avoided. Like in this particular case, you have to return file, you have to file the return, and government is going to extend the date 1 month, next month, government have to wait. So here there is no problem. It is automatically filing, because smart contract will automatically do this entire exercise. Okay, so all the transactions are transparent and tamper proof. It reduces the risk of fraud or mistakes or any bad practices. Immediately auditing from the transaction log can be initiated at any instant of time, because it is a ever growing ledger. So if I want to check, if I want to do the auditing, no need to take any exercise, or no need to take any preparation. At any instant of time, you can initiate the auditing. Okay, so this is the case study related to the GST, and this is the next case study that we will discuss, and after that we will shift to the Government of India initiative related to the adoption of blockchain, and we will discuss the recent report of the Government of India. Okay, and then we will wind up. I have other use cases also, but we will wind up by one. So the other use case that we will select right now is the land registry record. So I have already told you that what is the requirement to adopt the blockchain in the land registry record. So particularly there are 3 units of land register. The first one is the object, that means your land or house that you have. Okay, so all these flats or property you are having, which we can call it as an object. Second, rights available to the owner, that means rights associated with the property. So there are 2 type of right. What is the first one is the rem right, second one is the personam right. We will tell you what is the meaning of these rem right and personam right. So subject, the person or the title holder. Let's say I am the owner, so I am the person or the title holder. These 3 things are highly required in order to do any land registry. That where is the land, how much is the land. Hello, anyone have any? I request all the participants, please mute yourself. Yeah, thank you. So now, what is the meaning of rem right? So if you have your own house, let's say I have my own house, and no one can claim the ownership of that house. So that particular right, we can call it as a rem right. Okay, what is the meaning of this personam right? So let's say I am having my own house, but I have given my house to rent to some renter, and I'm taking some kind of amount monthly basis from my renter. So that particular right, you can call it as a personam right. So both the rights you can consider, like 90 years of agreement between the buyer and seller. So after 90 years, the actual buyer, actual seller will be the actual owner of the property, something like that. Okay, so this is the 3 things required for a land registry system, particularly in India. So now, how to maintain it, how to do it? So let's say we consider a very realistic scenario. in the real estate transaction, how the transactions are happen in at present. So let's say I am having my house. Okay, so this is my house and I want to sell this particular house. So what I need to do, I need to contact a particular real estate agent. Okay, and by taking the help of this real estate agent, he or she can float my request that I want to sell to different platform, and the agent checks but before floating this information, agent want to check the ownership, whether the flat that you want to sell is actually belongs to you or title is clear, no dues are pending. So the agent checks the land registry office that your house is legal owner and you are the legal owner of the property or not. So these are the very basic steps. After that, when the agent get a kind of a good report or satisfactory report, then the agent announces that the house is for sale. Okay, and let's say for example on a very next day, one person approached to the agent and that person want to buy the house. Okay, so now but the person is not having a sufficient amount to buy the house and he want to take some loan. So when the buyer want to take the loan in order to buy your house that you want to sell, then the bank also want to do some kind of verification about the property. This is a genuine aspect or real aspect. Okay, so then bank also need the same document, whatever is already taken by the agent, like 15 years, last 15 years, or title deed, title clear deed, or no dues from the municipal corporation. Okay, then the bank check the land registry record for the person or the ownership. Then if they are satisfied, the ownership is okay, then the loan is approved to the buyer and the buyer transfer the money to the agent. Okay, and you also transfer the required money to the agent. In this particular case, what is happened basically in this particular case? In this particular case, there is a duplicacy. Agent has also checked the verification of the property, bank is also checking the verification of the property, and sometimes do a kind of a re-verification also. So now a legal contract is made between the buyer and the seller, and the agent transfer the money to the seller, and after deducting some kind of fees, that means and in this entire example, this agent is the third party. Now, how to avoid this third party? I want to avoid this third party, and I want to avoid reason number 2, this re-verification of the document. This is the problem number 2. How can I do it? So now, if you want to apply the blockchain in this particular area, then the land registry is in the blockchain. That means this task is already going on across the pan India. And in some of the states, they have already completed this practice that all the land registry records, Sajra, map, all things are converted into a digitized form. Okay. And once the property owner if this entire information is available on the blockchain, then the property owner, after paying certain amount of fees online, he or she can check the ownership of their property and whether they are eligible to sell the property or not. So the buyer and seller can get connected over the blockchain platform. The bank can also check the status of the ownership over the blockchain platform. There is no need to initiate any other re-verification. Okay, so the purchase is executed using the smart contract. So the smart contract, where the seller transfer the ownership to the buyer, automatically the name is changed. Okay, because this thing is mentioned in the smart contract also. Whenever any buyer and any seller want to sell his or her home, then automatically it is to be transferred to the name of the buyer within the stipulated time period that is already mentioned in the regulations of the smart contract, and payment will be automatically transferred from the buyer's bank to the seller's bank. So everyone, buyer, seller, and the bank can verify status of the contract over the blockchain smart contract platform number of times. No need to report to the third party like agent. No need to go to the court or purchase a kind of a non-judicial stamp paper and do a kind of a verification of taking a 15-year record or 20-year record. No need to visit any municipal corporation. So blockchain in Government of India, like Andhra Pradesh is a leading state for adopting the blockchain. So Andhra Pradesh government already initiated the one project with the Sweden-based company, that is the Chromaway, to start up the blockchain to maintain land registry record. So if you want to explore it more, please explore this case study, very interesting case study that has already initiated by the Andhra Pradesh government. Okay, so a lot of other examples are also there. Bharat Chain is also there, but I will discuss these examples in a minute. So let me just skip some slides and directly jump, because I have already told you that I have a lot of case studies I have included, but because of the shortage of time, we will not discussing these case studies. Okay, because you know that we have already contributed a lot in the area of blockchain technology. So now very quickly in the 15 minutes, we are going to discuss about the national strategy on blockchain. What is the strategy of government of India for adopting the blockchain in the different verticals or different services provided by the government of India? Whatever I am going to discuss now onwards, these all are the vision of the government of India. This I have already taken from their legal document. Okay, the vision of government of India. So now the national level strategy for adopting the blockchain, they have divided into two parts. The first is the technological aspect and second is the administrative aspect. So what is the technological aspect? In case of technological aspect, they have created some kind of center of excellence in the blockchain. They have defined the single point of contact if you want to initiate in the area of blockchain technology, or from the administrative point of view, they have already defined the regulatories. Okay, so in the two aspects, they have divided this entire report, and this applications I have already discussed with all of you in my previous session, so no need to discuss it again. These are the potential applications highlighted by the government of India, where the government needs some kind of support from the company and academicians, okay, like us. So these are the applications that government of India or Ministry of Electronics and Information Technology, they have already highlighted. Now I want to highlight some of the statistics. So in case the Ministry of Electronics and Information Technology, MeitY, they have already created a center of excellence in blockchain technology in collaboration with CDAC, Pune, ID, RBT, and VJTI University, as these three are the executing agency. Okay, and apart from that, IIT Kanpur is leading in the area of blockchain technology. They have a very huge project from the government of India, particularly for the identity management. Okay, so the blockchain technology based solution already implemented as a pilot project from the government of India side, particularly sponsored by MeitY, and they have selected one Shamsabad district village in the Shamsabad district of Telangana state. As a proof of concept, they have already developed cloud security assurance or trade finance, and generic proof of existence framework they have already developed in collaboration with CDAC, Advanced Computing and Training School, Telangana state. Apart from that, they have already established the center of excellence. Government has already established in the area of blockchain technology. This was established by NIC, National Informatic Corporation, and the sole motive is that they want to accelerate the adoption and deployment of blockchain, particularly in the government services, not only restricting to a particular state but across the pan India. So the applications under the COE that they have highlighted, this is a national scenario in Indian context only. They have highlighted these applications: blood bank, DigiHan, public distributed system, land registry, GST back office, and excise management system. So these are the priority area that center of excellence established by NIC, they have already defined. NITI Aayog has already recognized blockchain as a promising technology in their vision document, and they have already highlighted that this is going to be a kind of a booming technology, particularly in the government sector. And CDAC mission in the blockchain technology is categorized into two levels basically. First one is the unified blockchain framework, and second one is the blockchain services. So they are working on development of the framework. Once the framework is ready, then they want to provide the blockchain services to the different state governments or central government like e-sign integrated with blockchain based proof of work existence. They are working on this particular platform or this particular problem. Blockchain applications. Hello. So Reserve Bank of India is already exploring adopting the blockchain in the banking domain also. In the government document, government has already given this use case that Mahindra and IBM, they have jointly collaborating on supply chain management solution, where SBI, State Bank of India, has associated with commercial bank and financial institution for blockchain based application pilot project. Yes Bank, Axis Bank, ICICI are also adopting the blockchain in their banking business. As per the NESCOM 2019 report, in India, the different states have already initiated the baseline use cases of the blockchain. So technological challenges, particularly if I talk about the first challenge that the India is facing nowadays is the performance and scalability challenges. Scalability means country like India, we are having heterogeneity state wise, center wise, then municipal corporations, then local panchayats, village panchayats. So how to scale up the adoption? This is the first challenge. Second one is skill set and awareness related to challenges. And that is the reason why these type of workshop is highly essential in order to disseminate the basic foundation related to the blockchain technology. Legal challenges for adopting the blockchain, like in-person verification, this is also one of the challenge. Or there is one act, Information Act 2000, in the context of transaction, how the government is going to change it. There is some localization problem also. So there are some technological and legal challenges for adopting the blockchain in particularly India. But this Ministry of Information, Electronics and Information Technology, MeitY, they have already carried out a SWOT analysis where they have highlighted the strength, weakness, and opportunities and threats. So I'm not going to the detail of these, that what they have written, but I will tell you in a very simple way that this is a very grayscale area for all of you, where a lot of things are in pipeline and you have more to contribute in this particular area. Okay. So roadmap for the blockchain technology adoption from the government of India side, they have already initiated the access value. Now they are on this particular stage, and after that completion of this, they want to scale up the deployment of blockchain and they want to improve its efficiency and adaptability across the pan India. Potential challenges to be addressed towards evolving shared blockchain infrastructure and cross-domain applications. Scalability, I have already told you. Data security, standardization of interoperability. What is the meaning of this interoperability? It means cross-platform and cross-chain protocols. How to, same you have developed for one application, how can you use the same for the other applications also? Okay, so these are some of the potential challenges which needs to be addressed. Need for national level blockchain framework. So MeitY have already defined that this can be the scenario of the blockchain framework architectural point of view, which the government is looking for, where you have on the top, you are having all the applications, okay, and all these applications are integrated with the existing services. And then you are having the access layer, because what kind of access you want to give. Then you have the asset layer, then you have the smart contract layer, platform layer, then shared ledger layer, and national blockchain distributed infrastructure. So this is the layered wise categorization that government has already identified or government has already placed in their document. Integration of important national level services to blockchain. Government has already developed some of the framework like DigiLocker. So your document, you can access it anytime, anywhere. That is already developed, DigiLocker. After that, what are the collaborating organizations and their responsibilities? So National E-Governance Division is implementing the project related to government. Then state governments are already, they have already initiated National Informatic NIC, National Informatic Corporation, or your Center for Developing Advanced Computing Facility, CDAC, or STQC. These are some of the organizations, those have already taken the lead, and what are their responsibilities in supporting the government for adopting the blockchain. Okay, so so these are the conclusion and recommendations that I want to highlight depending upon the use cases that we have developed. So government want to integrate the blockchain in all the emerging areas and try to integrate other emerging technologies also, like AI, ML, DL, how they are going to integrate. This is the challenge number one. Now, government want to create a kind of a sandbox environment where the development and testing of application go in parallel for offering virtual trainings, because country like India, sometimes it is not feasible, particularly in the era of COVID, to go to a particular place and train them. So virtual trainings. Regulatory aspects also government exploring, and government want to explore the potential of blockchain in particularly the healthcare sector, agriculture, energy, and the government services. So this is all that I want to convey to all of you. And these are some of the very important references. I must say that all of you just capture the screenshot of this particular slide, because this is very, very important legal document from the government of India side, that they have highlighted that these are the legalized documents that the government has issued. Okay, so with this we will wind up this particular session, although I have a lot to say related to the applications, but because of the limitation of time, we need to wind up this particular session. So in case any one of you have any question, then we will take your question answer. Any one of you have any question answer, then you can ask, or you can directly write in the chat window. The complexity introduced by storing every block on every node is very huge, especially considering the domain like governance. Can we optimize that, or it's in the genus of BCT and could not be worked to? Secondly, if off-chain storage is the answer to this, then it is pure BCT. Yes, off-chain storage is a pure BCT, because blockchain is storing what? Blockchain is storing the informations. Okay, so if you want to store the information in the form of hash, then also it is going to redirect directly accessing. Okay, this is the answer to your question 2. And answer to your question number 1 is yes, it is very much easy, that very much I can say the right. The complexity of adopting the blockchain is very much, but the structure is like that. We are having a single blockchain. Inside the blockchain, we are having multiple blocks. Each block will have its own hash, and each transaction will have its own hash. Okay, so yes, we can optimize the requirement. We can optimize it depending upon the requirement, or depending upon the application which is in hand. Let's say if you are optimizing considering the government perspective, then your perception may be different. If you are optimizing it considering the perspective of healthcare, then your perception is altogether different. So that aspect you need to check, that in which, considering what kind of application you are having in hand, and for which you want to develop the blockchain. Okay, so any one of you have any other question, please write, or you can write in the chat window also. Please write in the chat window if you have any question, or you want to ask. You can directly unmute yourself also. Otherwise, this session is end from my side. Okay, so I once again remains thankful to Professor Hiral for giving me this opportunity to share my view related to the blockchain technology. And I believe that it is going to be a good learning for all of you to understand the technicalities behind adopting the blockchain. Okay, so if you don't have any question, then the session is end from my side. Okay, thank you very much, all of you. Have a nice day.
Thank you very much, sir, for sharing your knowledge that how different governments using this technology to ease their task and helping the people. Thank you very much, sir. So we have some time if you want to share some notes that you are saying you want to share.
Yeah, no problem. That I will certain documents I have, and I am just make a kind of a email and make all the document as an attachment and send to Professor Hiral, so that she will share with all the participants, and this is going to be a good learning for all of you. And I have already told you that there is a requirement to have a very good textbook in the area of blockchain. So we don't have any textbook. We have a lot of edited book or 2 to 3 textbook available in the market, which will covering some concept of the blockchain. But according to me, these are not the book that we are looking for. They have captured or they have contained all the information from Wikipedia only. But there is a requirement to have a very good standard book, textbook particularly, not edited, in the area of blockchain. And I feel very privileged to inform you that with the hard work of my student or my team members, in a last 2 years, we have submitted recently last month the textbook which contain 14 chapters with implementation and all the codes. And the publisher is Springer. So maybe you people have to wait for next 2 months, and maybe by June or July, that book will be in the market. And this is going to be the first textbook related to the blockchain technology, which cover not only the fundamental theoretical part, but in each chapter you will find a lot of questions or answers to these questions, or specifically in every chapter you will find implementation, step-by-step implementation, how you can implement the different concept of blockchain in a very easy way. And that too, we have written this particular book in a very lucid language so that everyone can understand. And we have covered each and every aspect of blockchain in a very effective way, so that reader can understand that what is the technicalities in the blockchain technology. Yeah.
So
Over to you. Over to you.
Thank you, sir. Many congratulations to you and your team for publishing the first textbook in the blockchain.
Yeah,
Thank you very much, sir.
thank you very much. But still, we have to wait 2 to 3 months to have the hard copy and e-copy.
Sir, yes, we are eagerly waiting for it, sir.
Yeah, thank you. Any participant have any question? Please write in the chat window. Otherwise, the session is end from my side. Once again, thank you very much. Have a good day.
Thank you. Participants, if you have any question, you can ask it to sir. Otherwise, we will end our session here and we will meet again at 1:30.
So thank you very much, all of you. Have a good day. Yeah.
Thank you, sir.
Okay.
So participants, we end up our session here. After lunch, we will meet again at 1:30 p.m. and we will have an expert talk on the national education policy that is given by Dr. Ved Vyas Dwivedi.